Hello everyone and welcome back to the course. Today we will discover the truth, or at least the truth values of propositions. Let's dive in. In this section we will find conditions to determine the truth values of compound propositions regardless of their content. In other words, we want to be able to determine if the following proposition is either true or false. Before discussing the conditions that will allow us to determine if a compound proposition is either true or false, let us consider the following atomic propositions: P, Q, and R. Now, from those atomic propositions, we can create different combinations of compound propositions. For instance, the following. Now, the main question here is, how can we determine the truth values of those propositions? In other words, how can we determine if any of those propositions is either true or false? In order to answer that, we need to know the truth values of each of the individual atomic propositions. For instance, the first proposition, proposition P, is true because 25 is less than 125. Proposition Q is false because there is no integer whose square is negative. Proposition R is a bit more complex than proposition P and Q, but after some computations we can determine if it is true or false. As a matter of fact, this is a false statement, but we are going to assume that we don't know this yet. We don't know if it's either true or false. We can conclude that the compound proposition not P is false because this will say that 25 is not less than 125, which is actually false. As a matter of fact, the proposition not Q is true because Q is false. The compound proposition P or Q is true since at least one of them is true, namely P. As a matter of fact, if either P or Q or both of them are true, then the compound proposition P or Q is true. So, in order to have this proposition as a false one, we need that P and Q have to be false. Now, proposition P and Q is a false proposition because in order to make it true, both of them have to be true. But in this case, P is true, but Q is a false proposition, making the compound proposition P and Q a false one. Notice that if we assume that we don't know the truth value of proposition R, then proposition P or R must be true because proposition P is true. Now we need to highlight that a conditional proposition, if P then Q, is false only when the hypothesis, in this case P, is true and the thesis, in this case Q, is false. In any other case, the proposition if P then Q is always true. Finally, an equivalence proposition of the form P even only if Q is true when both of them have the same truth value, meaning P and Q are both true or P and Q are both false. If both of them have different truth values, then the equivalence proposition is false. Formally, we can say that the truth values of a proposition are the two possible alternatives that a proposition can have, namely true or false. We will denote the true value by T and the false value by F from now on. Now, it is crucial to understand that if we take propositions P and Q and we replace them by propositions P prime and Q prime, such that both of them have exactly the same truth values than P and Q respectively, then all the compound propositions will retain their truth values. Now, in propositional logic, we will not deal with specific propositions. Instead, we will use letters that we will call propositional variables, which, together with logical connectives, we will be able to construct propositional formulas. From now on, we will use lowercase letters P, Q, R, S, and so on to denote propositional variables, and uppercase letters when we denote propositions with a specific semantic value. This new direction will allow us to focus only in the truth value of each of the independent propositional variables and not in the semantic value. Now, if we consider the following propositional formula and we substitute each of the propositional variables with a semantic value, for instance, the following, then the entire proposition is true because the proposition P or Q is true due to the fact that proposition Q is true and the proposition R is also true. Therefore, the entire proposition is true. And that's the truth. Now you know how truth values work and how they fit into propositional formulas. In the next chapter, we will learn how to deal with truth tables. See you in the next lesson.